An immense honor for me to welcome as our first keynote speaker, David Lorge Parnas. Please allow me a few minutes to introduce him, especially given the many young people who are attending, and we may not be aware of his contributions. So beyond his many honors and awards, it is actually difficult to overstate the impact Dave has had on the development since its inception on the field of software engineering. Among many other achievements, Dave literally invented in the early 1970s the concepts of information hiding and modular decomposition. He was one of the first to work on product lines, which he called program families, and viability in software systems. He provided early incredible insights on how to provide precise and formal documentation and specifications in a practical way, in particular in the context of reactive systems. And he was one of the first to rigorously investigate software evolution and aging. Last, his work on assessing safety-critical software has had a lasting impact. And beyond technical aspects, Dave has also played a major role in advocating early on software engineering as a true engineering discipline through a paper with a controversial title called Software Engineering and Unconsummated Marriage. And he also advocated the need for professional ethics in software development, which was of course related to the fact that software engineering should be organized as an engineering discipline. Today, Dave is going to provide his perspectives on the regulation of AI and AI-enabled software in general. And we look forward to hearing from you. Dave, the floor is yours. Use a green arrow to go forward.
Hi. As I've listened to all the reminiscing about ICSE, a memory came to me. I attended ICSE before there was an ICSE. I remember being at a conference in Los Angeles where we decided to hold this series, to form it, and I don't think any of us ever dreamed that it would ever become as big a thing as it has become, or the kind of thing that it has become. And it actually surprises me. I'm also surprised because I suspect that a lot of my audience wasn't alive then. But anyway, as those of you who know me know, when I give a talk, I always hope to change people's mind about something. I tend to give talks that are controversial, and I end up making some people hate me and some people love me. I hope the haters outnumber the lovers. And if I have one goal for today, it's to see the two rooms that are dedicated to artificial intelligence very empty. Let's see if I succeed. I expect the authors to show up, but I'm hoping nobody else will. Okay, so I'm giving this talk because I've been retired for about 18 years, but I've been watching all the hype about artificial intelligence and the call for regulation of artificial intelligence. And I come by this interest very honestly because I began my career at Carnegie Mellon, which was one of the dens of this iniquity. And I was forced to take AI courses. And I have tried to forget them, but I've failed. Anyway, I'm going to begin by reminding people that this is a talk for an engineering conference, and that I have a very clear idea in my mind because I went through a lot of propaganda sessions when I began my engineering studies before there was anything called software engineering. And we were told that it was our job as engineers to make sure that whatever we produce is really fit for use by other people. And that whatever we produce, we know what it does, and that it's reliable enough. We don't expect perfection, but we expect it to be reliable enough that people don't regret having it. We expect it to be trustworthy, meaning that it was not likely to produce any great harm. And we were reminded, and this is very important in other areas of engineering, that it had to be designed for maintainability. And that's a big part of what I'm going to talk about today. I'm going to talk about regulations, and I just want to remind everybody what I think we expect of regulations. The most important thing being a precise definition of what things are subject to those regulations. And then we want to make sure that if a product satisfies the regulations, that they are fit for use, and that this is sufficient to guarantee that the product can be trusted. We want the regulations to be something that you can actually do. I've seen a lot of regulations that never get met. We want them to be enforceable, which means they have to be very clear. And we want a minimum of red tape, but I'm not like some of the politicians of the day who want to get rid of red tape. I believe that if you follow every piece of red tape back to where it began, you will find something that went wrong that they're trying to correct. So we have to be very careful when we get rid of red tape. Now I want to switch to the other half of the topic, and that is, what is AI? And I want to make sure that we think about a scientific definition, one that's based on measurement. Could be a predicate, something is either AI or it isn't, or we could try to measure its IQ in some way, but we want it to be clear and ambiguous. And I'm going to go back to Turing's original paper, and there's a question that I think people overlook in his paper. He says, and this is a direct quote, I cut and pasted it to be accurate, the original question that he was trying to answer was, can machines think? And he thinks the question is too meaningless to deserve discussion. And in spite of that, a lot of people who cite Turing have continued to discuss it. I also want to remind you that what he proposed as his imitation game was called a closely related question, by which I think he was trying to tell us that it was not a test for intelligence. You know, many people now give it as a definition of artificial intelligence, but I don't think that's how he meant it. I think he really thought of it as an example of what would be a scientific question, one that was based on measurement and precise definitions. Now, over the years, and I think it's about 65 years that I've been doing this, I've been looking at various definitions of AI, and the most common one is that it's able to pass the Turing test, which he didn't call the Turing test, thank goodness. He called it the imitation game, and I'm going to come back to that a little later. And I'm going to discuss a couple of programs that actually passed that test and talk about them and what we can learn from them. A little later, I heard people say, well, it was heuristic programming. Now, I'm an engineer. I didn't learn anything about classical things like Greek. So I had to look at a Carnegie Mellon PhD thesis to find out what heuristic meant. And one of those AI theses said that it was a rule of thumb that didn't always work. And then I realized that if I was writing a program and it didn't always work, I had a choice. I could either fix it or call it AI. Anyway, another definition that I have seen is that it does a job that used to require humans. Well, when I was young, if you can imagine that, things like copying manuscripts required humans. Operating elevators required humans. Shifting gears in a car required humans. So I don't think that's a very good definition. There's also been definitions like rule-based. I remember reading from a colleague in Germany who used to fight with me about artificial intelligence, that when he was doing it, he thought it meant it was a rule-based program. The common one now is it has to be a neural network. And one of the things that bothers me about that definition is that these neural networks aren't actually built as neural networks. They're simulated on usually graphics processors, and that means whatever they can do could be done by a graphics processor. So I'm not clear to me that that's a good definition. But I have tried to look at what they have in common. And to me, the main thing is that they try to create the illusion of intelligence. Got this idea from one of my mentors, the first winner of the Turing Prize, Alan J. Perlis, who told me that the people in the department he formed that were AI people were illusionists. And that's why I've come to think that it should be called II, not just because it's a notion of regret like II, but it's imitation intelligence. And we have to remember that Turing did call his test the imitation game. So maybe there's some basis for that. And I find that these programs tend to imitate human behavior in two ways, either internal imitation, by which I mean they get their methods on how people say they solve their problems, or external imitation, meaning that they try to imitate the visible behavior of a human. Many of what I call II systems do both, but either one is enough. And now the next question I wanted to ask is, why would we want such things? We already have billions of things like that. They are controlled by neural networks. They are rule-based, except for certain politicians I won't name. They are mass-produced by unskilled labor. And the best part is that people love to produce them. Now, what I think we really need is systems that do things that humans cannot do, or do things that humans don't want to do, or do things better than humans do, or use better methods than humans say they do. The reason I put the say they in there is one of the early good results that came out of AI was a study of how people play chess. And they find out that if you ask somebody how they play chess, what they tell you is not what they do. They track them with eye cameras, and they find that they're not doing what they said. And the other thing you find is that after that, they tend to play worse because they start following the rules that they stated. So from this, I have concluded that we should never ask humans how they think and then believe them. Now, to give you just a little idea of what I mean, why I'm doubtful about AI, here's my notion of how an AI designer would build a washing machine. Right? You look at how people wash clothes before we had washing machines. They used their two arms, one held the washboard and the other scrubbed the clothes. So now we have a robot arm with a washboard. Adding numbers, I don't know about you, but I know how computers add numbers, and it's not the way I do it. I know one time going to papers on how to find the way through a maze, the AI papers all use much worse methods than the best-known algorithms. And facial recognition. I remember studying how people were doing facial recognition, and what works is not how humans do it. And that's why I have doubt about this whole assumption behind AI. And what we find is that these programs are very often very inefficient, that people don't know their conditions of applicability, that they use huge amounts of energy, and people are actually talking about waking up nuclear plants in order to drive AIs. They're often unreliable, they're often not trustworthy, and they're often even not understood what they will do. I remember reading about hearing one of the famous people currently in AI, they call him a godfather, and he was bragging about the fact that his program surprised him. And I remember thinking that if I was an engineer and my product surprised me, I would consider it a failure. I'll give you a funny story. When I was a young assistant professor, I became worried that I didn't know what was a good PhD topic for my PhD students. So I decided to ask 3 famous professors. One was Alan Perlis, I'd mentioned him earlier, and he looked at me and said, "You'll know it when you see it, Dave. Get out, I'm busy." That was the best answer I got. Then I asked a very well-known AI professor, who I don't want to name, and he said, "I'll give you a good one and a bad one." And then I asked Bob Floyd, who many of you may remember was an inventor of many things outside of software engineering that were really practical and useful. And he said, I can give you an example of a good one and a bad one. But what makes this story funny is that Floyd's example of a bad one was the AI prof's example of a good one. And one of Floyd's great contributions to the field is that he worked on parsing of grammars, and this was an AI program that generated grammatical parsers. And his first question is, what class of languages can it answer? And the student didn't know. And his second question was, does it always work? And it didn't, so it was AI. And he came to the conclusion that this was not a passable product, and he left Carnegie Mellon and went to Stanford. I'm also hear a lot of people worried about deep fakes. And when I look at what they're talking about, I find this is just a new word for good forgeries. It's easier to do them now that we have computers, but we don't really need AI for deep fakes. And then the big buzzword today is machine learning. Well, I think that this is just a fancy word for having a program that collects data while it's running and uses that data to improve its performance. And if you think about that, there are a lot of programs that do that that aren't called AI. A lot of banking programs, for example, start warning me when I'm using my credit card too much and stuff like that. So when was the first time I saw a program that did this that I really had to think about? There was a fellow named Robert Dubček, had worked at RAND, was a student with me at Carnegie Mellon, and he built a program to do penny matching. It's actually a device, he hardwired it. And the funny thing about this program was he would challenge all of us to play it. It would start out stupid, and then it started getting better and better, and it beat all of us. And we tried harder and harder to beat it, and we never could. And then, being an honest man, Bob showed us how it worked. And we realized that it was absolutely trivial. And if you'd seen how it worked, you never would have thought of it as intelligent. But if you watched it beat you, you felt it was intelligent. And what I find is that machine learning is often a very lazy way to write a program. I hate to say that to people who believe in it, but if you don't want to think about how to solve a problem, you try to get the machine to learn. And I don't think yet machines come anywhere near close to that. And they're often bad because they depend not on the code, but on the data, and the data is very important. A lot of these AI programs are based on statistics. And as somebody who only has ever had one course in statistics, I feel I'm an expert. And I think that any program based on statistics is really very dangerous, because statistics is really a method of dealing with ignorance. I mean, we say things are random, but what that really means is what Einstein said when he said God doesn't play dice. He said there really was a reason, we just didn't know it. Even when you throw dice, the physics determines what ends up on top, but we don't know enough to do it. And very often the right solution to a problem is not to use statistics, but to try to gain that knowledge. And I'm just very wary of any AI program, well, and any, especially the ones that use statistics. Because getting the right data is the hard part, and this is something that I think even the AI people agree to. The data is enough to make it do strange things. Now, so another claim that I've heard, and it's usually among people who aren't computer scientists, is that somehow AI can do things that other things can't. And I think that's frankly nonsense. I don't know any reason why anybody would say that. First of all, I grew up as a hardware designer before I got into software, and it was a classic reasoning then. If you knew what finite state machine you wanted, there were many ways to build it, and they would all act the same. And I don't see why anybody would think that just because you've built it of rule-based programs or wrote neural nets or something like that, that it would do more. In fact, the proof of that is that they're simulated on things that are fairly conventional designs. And usually, if you look at them, they can be done better. Now, one of the reasons this is I believe that our brains are very special things. Now, I don't mean they have any magical powers. I mean that they grow inside a human skull. They have to start out small and grow. And if you're an engineer, you know this is a huge constraint. Everything's built out of a small number of cells, and they grow, partly inside the mother, and they continue to grow after they get outside. And when we build computers, we don't have to do that. We can use all kinds of different parts and all kinds of different material. And I don't see why we would, as engineers, want to be that constrained. If what we're interested in is solving the problem, then why not take advantage of it? Why imitate what the brain does? And now I want to turn to there are a lot of people who say they fear AI. When I look at most of what they say, I think they're really talking about automation. They say AI will take jobs. Well, automation takes jobs. Well, AI can make serious mistakes. Well, I hate to tell you this, but automation can make serious mistakes. AI can violate your privacy. There's a lot of perfectly conventional automation that can violate your privacy. And they've been doing those things for deadlines, and it was before people started claiming that there was AI. Automation is a good thing. I devoted my career to trying to make it work better. And I think it can make work easier and be reliable and trustworthy, and it can be better if it's designed with that in mind. But calling it AI doesn't change any of that. And I find that calling it AI often comes with sloppy thinking. People say AI will affect productivity. Well, to tell you the truth, I think automation has affected productivity. Many of the things we do today, we do much more productively because of things, but we have to be careful. When I was first learning to use a computer for anything other than real computing, and I learned to use word processors, people did studies and found that word processors actually reduced productivity. It just turned out that people made many more versions. They became much more perfectionistic. They would reprint some, they even used more paper because people would reprint them and then find they didn't like the way it came out on the pages, and then they'd reprint them again, something we never did when we had to ask Dorothy to type it over for us. You know, that's just the way it is. So I don't think that AI is likely to be much better than that. Now, the other early AI program I want to talk about is Chatbot, done by my late friend, Joe Weizenbaum. He built a program called ELIZA, which would carry out a thoughtful conversation with people who were looking for advice. And I've shown this to people I know who are psychologists. They immediately recognized where it came from. It came from a school of psychology called Rogerian, and it basically just plays people's words back at them. And this program, as Weizenbaum told us many times, often passed the Turing test. But it wasn't written because he wanted to pass the Turing test. And this is something that Joe made very clear to people who listened to him. He wasn't trying to pass the Turing test. He's trying to show that the Turing test wasn't worth working on, that he didn't think it was a good test for artificial intelligence. And I think if you look back at Turing's paper, I think he would have agreed with Joe. He didn't live long enough that they ever talked to each other, as far as I know. But it was very clear. Joe was also an honest man, made all his code available to us. One time I met him in Germany, and he was talking to a mostly bilingual audience, and he demonstrated ELIZA learning to speak German. And it was really convincing. It really fooled us. And my conclusion from all of that is that people are very easy to fool. And now I look at today's chatbots, and I find that they can actually, much like ELIZA, they can write about anything. But I don't find that what they write is worth anything. It doesn't show any insight. It doesn't show anything new. It's sort of like a high school writing exercise. It's sometimes inconsistent. It must be fact-checked. It can even work, as they say, as an illustrator. I tried it just once, and I gave it the prompt, eating the leftovers in the refrigerator, and here you see the picture that came out. This is true. I just tried it once, and that's what I got. It's a picture of a man sitting inside the refrigerator eating leftovers. Now, this is not what any human being who's ever seen a refrigerator and used a refrigerator would ever do. But what it illustrates is something that I want to say in a different way in a minute, that it lacks understanding. It really does not know what it talks about. And this is why I would never trust any chatbot unless they really change what they're calling chatbot, because they don't know what they're talking about. Now, to do this, I have to change to a slightly different topic. But I've had the experience a couple of times in my life of trying to learn a second or a third or a fourth or nth, maybe a first language, because some people don't speak English is very good. But what does it mean to understand a language? People often say, well, I understand language X if I can give you a word in my language that means the same. But that's not really what it means. It means you know the set of circumstances in which that phrase or sentence would be used. And if you can communicate with other people if they also understand that and they have the same set of circumstances. And circumstances is a lot more than what was said before or written before or what was written afterwards. It's all about what's going on. And I'll take a simple sentence. I have a headache. What does that mean? Well, you can say it if you actually have a headache, which I'm happy to say I don't. It's something that says he doesn't want, the speaker, he or she doesn't want to do something, and they need an excuse. I have a headache tonight, dear. Then somebody says, Dave Parnas has a headache. And that means he has a serious problem. I have a serious problem with this guy. And it often means they want help in fixing the headache, which has nothing to do with their head. But you don't know that. And the way they train chatbots today, by feeding them lots and lots of text, they're never going to know the circumstances that are behind it. And that's why they're always going to continue to make stupid mistakes. I wrote in my abstract, I think they'll never be trustworthy. And I really mean that, because they're not giving people the circumstances behind it. Now, there are times when I would use AI. First of all, if the answer doesn't really matter. There are a lot of times, a lot of things people give to AI. You get it wrong, you shrug your shoulders and you go on, playing certain games and things like that. If computational efficiency doesn't matter, because they're seldom the most efficient way to solve a problem. If I like hacking, and I want to demonstrate what a good hacker I am, I would use AI. I love the pinball machine effect. That's why we used to write programs. When they work, you get a big doing. And if you don't work, you just get a dull thud and you get to try again. And not many people in this room don't remember pinball machines, but look them up. If I wanted a never-ending grant, why? Because with AI, it's never good enough, but you can always show progress and get more money. And I think AI researchers are always suggesting they need just a little more money in order to make their AI better, and they're never done. Now, it's become very popular for some, not all, AI purveyors to warn of the dangers. And every time I hear that, I think that's very self-serving. Because what I'm hearing is, AIs can be dangerous. Please give us more money to make it safe, right? It's kind of like I've even heard people saying we should use AI in order to check on AI. And I keep thinking, this is what we call the hair of the dog that bit you, drinking alcohol to get over a hangover. And I think we're just going to get more and more AI, and we're going to have more and more headaches. And I have to ask myself, why did they bother to create such a dangerous tool in the first place? And the answer is, it wasn't because they were engineers. They just like doing it. And why do they say that chatbots hallucinate? Well, this is a euphemism, because hallucination is a euphemism for bugs. But it doesn't sound as bad because it makes the thing sound more human. So it sounds like they've succeeded, right? As far as we know, only humans hallucinate, right? And the same thing happened with bug, it's just a euphemism for error. And error sounds a lot worse. It sounds like you did something wrong. Bug, it's just nature, right? So these programs always make errors, and I think they always will. And if an engineer makes an error, we know we have to correct it. But if an AI makes an error, it just makes them seem more human, and they can brag about it. And they even wonder who wrote the titles for some of these AI experts, like a godfather. I have on the screen the definition I got out of my dictionary on godfather, right? It's somebody who takes care of a child, or it's somebody who directs a criminal organization. Is AI a child? Well, it's certainly not grown up. Are AIs promoting a criminal organization? Maybe that's what I'm saying. Then I hear them called a pioneer, and it's a person who's the first to do something. And frankly, the people who were the first to talk about AI were dead when I started to learn about it. The people who are alive today, none of them are pioneers in that sense. The word I would use is Pied Piper, right? Because Pied Pipers are people that offer us something strong but somehow enticement, but it's delusive. It misleads you. And they lead you with irresponsible promises, and they have charisma like politicians, and attract followers, and a person who, it's hard to read this, who entices people to follow them. And AI people are doing all those things. I think the biggest danger of automation, whether it's AI or not, is sloppy programming. People overlook cases, they overlook side effects, they often have rules that interfere with each other, they have capacity limitations that they want to forget because they believe in the infinite Turing machine. They have methods that seem to be working until they fail. I've written a lot of those. And they have products that cost much more than the better products. All those things, I say, sloppy programming, and it also sounds like AI to me. Now, these things, I think, happen because you're trying to imitate people instead of analyzing the problem and solving the problem. Here's another funny story. This is Ottawa-based. I was at McMaster University at that time. We were interviewing a new PhD from a university up here who had done an AI program to do object recognition, which is what it was called that week. But I was at that time in an engineering department, not in the computer science department. And the interviewers for this guy included signal processing experts, and they immediately recognized what he had done as a special case of an algorithm that was well known in signal processing and that didn't work very well. And they told him, this is not a new method. It's well known and it's not the best one we have. And his response was, well, it's new to AI. He didn't mind that it was known to engineers and that there were better methods. It was new to AI. And I think that's still a thing because it's a very self-contained field. Meet an AI person and see if he reads outside his field. I don't think many do, at least that's my impression. And why is it such a big thing today? It's just because there's a very active fan club who are very good at hype and have discovered a gravy train. And this has been true for a long time. When I was back at Carnegie Mellon as a graduate student, so it's a long time ago, AI was the best way to get money out of the DoD. It always was, and I think it still is. And people want to believe that we can do it. I think even Turing wanted to believe that we could do it. But what I learned from all of this is what I learned from Joe Weizenbaum when he showed us ELIZA, is that people are very easy to fool, and people want magic, and they look for it. So I think engineers can do better, And the first thing I would ask is that you don't use the term AI as if it meant something. I see people taking pictures of these slides. I'd be happy to send them to anybody who wants them. So you don't have to, as long as you figure out where my email address is. And you might get an AI to do that for you. It's not hard. Anyway, I think what engineers should be doing is studying the problem, not the heuristics that people say they use to solve it, and not to be impressed by AI achievements, because every time I think we see an AI do something, we're impressed very often by something that's very simple. Like I hear people saying we have trouble in Canada with a payroll program called Phoenix, and I keep hearing people say AI could do that better. I wouldn't be surprised if Phoenix was AI, but it has all the properties. No, I know it isn't. But, well, no, I don't know it isn't because I don't know the definition. But I don't think any of these things would really impress us if we thought about it. And I think that's what I'm asking you to do, is to think about this before you use that term and make sure you can define it and say why we should do it before you use the term. And now comes the question of why do we want AI to be regulated? The answer is it can be dangerous. We don't trust anything that we think can be dangerous, and there's no reason why we should trust AIs in any critical application. Now, and we often try to have regulations to prevent that. Now, I think software in general has a horrible track record, and that's why we have these conferences. That's why we met in Los Angeles all those years ago. It had a terrible record then, too, and it still does. And the strange thing is that we regulate the building of bridges. There are huge standards, but not the software that people use to build those bridges. And I think we need to ask why software should be an exception. Now, there's some easy issues about AI. Should it be illegal to AI to do your work for you and claim it, pass it in as an essay, or submit it to this conference so that somebody has to have an expert look for an AI paper? Of course, it should be illegal to ask an AI to do that or a real eye to do that. Why is that even a question? Same with plagiarization. If it's illegal for people to do it, it's illegal for... Should it be illegal to try to imitate other people? Well, unless you're on a comedy show, yeah. Should it be illegal to make jobs obsolete? And here I say no, because that's what AI has been doing, and that's why our world is so much better today, when it is better, because a lot of things we have automated. We don't have elevator operators anymore, for example. There are lots of things like that, and I don't think that's what we should be regulating. One of the questions people have asked, and I don't understand this question really, maybe you'll tell me why, is who's liable for damage done by an AI? Now, for engineers, I think this is a standard question. It's the AI that's liable. It's not the AI that's liable. It's either the people who made it or the people who use it, or both. The people who made it have a duty to have a specification for it and to make sure it meets that specification. People who use it have to make sure that they have read the specification and they're not using it outside of the specification. And if it doesn't work, it's not the thing's fault. It's just a machine. Whatever we call it, it's just a machine and it's not their fault. So using the label AI doesn't change this. Now I'm running out of time. I can't see my watch up here.
12 minutes, but we'd like time for questions.
Okay, so I'll take a couple more minutes and then we'll have time for questions or stones. I think what I would like, well, here's a list of things that I'm going to skip that we won't have to do. But here's why I don't think we can have AI regulations. We can't really regulate AI because nobody can define what set of programs it should apply to. It's not defined, so everybody can say, and I've seen this happen in all kinds of fields, You accuse somebody of violating the rules for, say, engineering. They say, I'm not doing engineering, I'm doing physics. Or I'm not doing engineering, I'm just a tinkerer, or whatever they say. It's very hard to define those things. That makes it very hard to regulate them. There is regulation for engineering, but it really doesn't work. And why do we need it? Well, the same thing we need it for any other engineering products, because things don't usually work. If the answers a system gives don't matter, then we don't need to regulate it. But if it does matter, then we must regulate it. The amount of regulation doesn't depend on what we call it or how it's built. It depends on how important the answer is. Okay. And I don't want to accept the excuse that software errors are unavoidable. I think it's a myth. It's a very convenient myth for people who want to cut corners. But as this picture of an old Hollerith card, there are a few old people here who will remember them, shows that's the last time we were supposed to cut corners in computers. If you look at the upper right-hand corner, it's cut. Okay. We don't blame the thing. That's the point of this slide. We do not blame the thing. We blame the people who use it or the people that build it. And what we should be doing is trying to regulate critical software rather than trying to make regulations that apply to AI. And I've already said what I mean by critical. There can be degrees of that and degrees of strictness to the regulations as a result. But it doesn't matter whether you call it AI. If it's a software computer system, there should be some regulations that apply to it. And right now, there really aren't. And that's why we get so much terrible stuff. I once lived in a country where they didn't have many regulations for building houses, and I never saw more errors in a house than the one I owned. So here's what we should be requiring. First of all, known behavior, specified, precise behavior. And I don't want anybody saying it surprised me and being proud of it. If they don't do that, if they can't say what their product is going to do, why would you possibly trust it? And that having a precise behavior specification is very useful for testing, for regulation, even for lawsuits. It's a very important thing, and we don't do it. I've only once or twice seen any requirements or behavior specifications that actually did the job. The architecture, I think the architecture, people used to say, well, I'm an artist when I write my software. Don't tell me how to structure it. Well, the trouble is people have to check it, people have to maintain it. And so the architecture is very important. I have on this slide, but I'm trying to hurry, a list of aspects of the architecture. But there's a paper I wrote a few years ago that I think summarizes what I mean by architecture. And if you want to think about regulating that, I think you should start with that paper. I'm sure you can add to it. We ought to regulate the amount of testing. And one of the things that I want to see more of is independent testing companies. But I want that testing to be based on well-documented function and well-documented architecture, because that's the only way you can have effective testing. And I think we should have specialist testing companies who come in from outside and look at it, so that you have three eyes. I'll get to the third eye first. I feel the same way about inspection. People argue about which is more important, testing or inspection. I think both are very important. I've written papers about both, and I think there are lots of papers about testing, far more than I have written, and they're much better. So I think inspection, however, is something that can be done badly or done well, and some of the papers on how to do it badly. And I think it's very important that we require that any critical product be inspected, and inspected by very thorough methods. Now, and finally, and I think this is very close to finally, I think we should be regulating who can write critical software. When it comes to building bridges, you have to be a licensed engineer. They have to have had an accredited education. It's far from a perfect system, but I think we should be doing it for software. Now, Canada has tried. but I'm very unhappy with the regulations and the accreditation. And I think it needs a great deal of improvement to come up to the standards that we know how to meet. So here's a summary of my talk, what I would like you to remember. First of all, there may be many reasons to be interested in AI, but engineering isn't one of them. It might be a great way to study psychology, but it's not a great way to build things. It must be regulated, but not as a special thing called AI, because that's pretty much a meaningless phrase. I think it must be regulated because it's a computer system and a critical application. And finally, those regulations need to focus on quality, and the previous slides talked about that. So now we can have questions.
Thank you.
Yes, please. I didn't want applause. I wanted some people to boo, so they get preference in the questions.
So, Andreas, I think you are first. Yes. You.
Thank you very much, David, for this very inspiring and insightful talk. You may not remember me. 40 years ago, I was a student at Technische University of Darmstadt. And,
I know.
And we invited you to give a talk on modularity and, at the time, the Reagan Star Wars system. Thank you very much, very appreciated. And the lessons that we had up there and the lessons that you put up today are still very valid for us today. You said that AI is often not a good solution for a well-defined problem, and I fully agree with that. But the real world happens to be often very undefined or not well-defined. I'll give you an example. You want to build a piece of software that recognizes a cat. What is a cat? Very simple question. Cat is a mammal. Do you want to build a mammal recognizer, a fur recognizer, a whiskers recognizer, maybe something that specifically checks whether it moves like a cat? All of this requires an amount of specification and definition that is extremely hard to do, very hard to get in a precise way. And this is where artificial intelligence systems trained on appropriate image data, video, whatsoever, shine. So whether we will build these explicitly or implicitly, they will always have a certain amount of accuracy and inaccuracy, and we must live with it. So what's your take against such, say, image recognition systems?
First of all, I don't think that it's a simple question to what is a cat.
It's a simple
but
question.
Besides that, second, I wanted to say that I felt real fear when I heard you were one of my Darmstadt students, because I remember they were known as the Parnas Beschädigte, the people who were damaged by Parnas. But now we'll get to your question. The first thing I learned as an engineer is that if you have an undefined problem, that's what you work on. You define the problem. Now, you might use anything you want to better understand the problem, but before you start building a product for other people to use and depend on, you should be defining the problem. And I think all the AI people I've known over the years don't do that. They just start playing with it, and eventually their understanding of the problem somewhat increases and the program gets somewhat better. But as I said before, it's never perfect, and that's great. So I don't know if that's my answer, but I think it means that you just didn't do enough work before you started designing. Or maybe you should have turned the job down. Like, I don't know what a cat is, therefore I won't write a program that recognizes a cat. If you tell me what you mean by cat, then I'll do it. That kind of thing. I hope you consider that an answer, and otherwise I'll cower on.
Thank you.
Thank you for this extremely insightful talk. I will bring home and cherish that. My question is fairly simple. So you talked in the beginning about circumstances. I wonder if it is advisable and a better idea to standardize the circumstances, the scenarios in which AI would be eventually applied, rather than the technology
I'm sorry,
itself.
I'm having trouble hearing you. Can you move closer to the microphone? Or?
Like this is better?
Oh, much better.
Okay, sorry. The question is, you mentioned circumstances in the beginning of your talk. Is that a better idea and feasible or advisable to standardize the circumstances in which AI is applied rather than the technology itself?
Well, I think the circumstances I was talking about were what you need to know to understand a language or more than one language. I don't think I really understand the rest of the question.
For example, there are many examples in our society about biased use of AI technologies, for instance, for hiring people. Should we regulate, for instance, the hiring process and eventually if we should apply technologies at all rather than the technology?
Well, first of all, I don't care what technology they use as long as they can say precisely what they mean. And I think from what little I've seen of the programs used to screen out people when you have 20,000 applicants for a job or something like that, is that people don't really know exactly what they're ruling out. They just want to make the numbers smaller. And I don't think that should be allowed whether they use AI or not. I think they should say, we're going to screen on these criteria, state what they are. They'll find their program can then be written more simply, and it'll be more useful. And people might reject that. They say, no, we don't want us to discriminate on the basis of gender or something like that. And if you wrote that down, that's what you're doing, and then people can reject it. If you just sort of say, here's a big complicated program, and it'll screen things, and you don't know what its definition is, you shouldn't use it.
Last question.
Thank you for this, I say, inspiring, but at the same time, making people think differently about this computing paradigm, I would say. Let's forget AI and call it like a different computing paradigm. I want to ask a question about a different perspective, so the equity perspective. And very often we see equity from like the negative part of AI, but there is a positive one. There are some documented studies that shows that we have more chances to have our papers accepted in conferences if we are English native speakers. Same thing for tutoring students. And we can observe as academics big changes for students using this assistant, AI assistant for natural language processing or even tutoring for their courses. And this, in my opinion, brings a lot of like more chances to people who do not have chances before. So what is your thought about that?
Well, I think what's important with those programs, and I know my own daughter tells me she uses that when she has to write French, and she lets AI check it for her, is that she checks it. She reads it again, she knows enough French that she can tell if it's really saying what she meant it to say. And I think in those situations, you can use AI because it doesn't matter if the answer is wrong, you'll catch it. Where it's dangerous is where you don't have time to check it, or you don't bother to check it, and that's when it can be dangerous. So the application you mentioned, I don't have a lot of trouble with.
Thanks.
Thank you very much. A token of appreciation for your talk.
Oh, thank you. Okay.
So thank you again, and I think we have a break now.